family mode.
Very good morning and welcome back, friends. I hope all of you can hear me. Please, can I get yes in the chat window? Good morning, Tushar. Good morning, Anurag. Good morning, Ranganath, Kopi, Venkat Chitti. Good morning, Joshua, Deepak, Vivek, Vishwajit. Good morning, Vinod, Chandan. Good morning, friends. Good morning to all of you again and welcome back. Yes, Madan Mohan, Ratmesh, Ankur, Cyril, Ankita. Good morning. I hope this week all of you got little time to practice, right? So can I get a small feedback on MapReduce, friends? All of you are comfortable now, why mappers, reducers, partitioners, combiners, and probably one or two use case also you might have just tried, right? So please, can I get some feedback on it? Good morning, Anurag. Ankita says yes. Word count, maximum temperature, yes, Anurag. Yes. With this, that's what I think I have also given that sal count example also, right? Sal count, then just a salary programs, right? Okay. So I hope those basic things, basic data flow, and then probably we have understood how we can analyze text-based data, right? So before I go, just maybe 5 minutes, let us spend on basic, questionnaire on MapReduce, right? So what decides number of mappers? Can I get a good example, friends? Vinod was able to try some examples. Fantastic, Vinod. So I got answer from Vivek, Tushar, Deepak. So Shiva, you say number of blocks, but again we discussed something else like number of input splits, right, Shiva? So input splits, yes, Sankita, Madan, Ranganath, fantastic. Madan, it is input splits based on input split, right? Yes, fantastic. Ranganath, Vinod. So input splits decide because as a job startup, right? So blocks when they will be created, they will be created when you move a file itself, right? When you copy a file to Hadoop, blocks will be physically cut and kept. So input splits will be created as because they are logical files. They are just a reference to these records inside that blocks, right? So now record by record reference, these input splits will be created by input format. So input format knows what is the delimiter. So with that delimiter reference, it creates record by record reference. Actually, we have one class called record reader. Record reader with the help of input splits creates key value pairs input to the mappers. I hope all this we have understood. Then data flow between mappers, reducers. What is the default number of reducers? What is default number of reducers? One. One, right? Pratmesh, it is one. By default, it will be one, right? I hope all of you got this. And we can also configure multiple reducers. So what decides which key has to go to which reducer? What decides which key has to go to which class decides which key has to go to which reducer? So I got a correct answer from Ankita, Vinod Kumar, Deepak, then Pratmesh, Vivek. Others, can you try again? Madan Mohan, yes. Yes, Anurag. Very good morning, Arun. Arun, I was just checking previous class, that is MapReduce questionnaire. We were doing some basic questionnaires to just revisit, right? So what decides what decides which key has to go to which reducer is the query. Can you answer it? So, I am seeing combiners, I am seeing shuffling. See, shuffling best, that is default shuffling happens, that is true. But in default shuffling, we will not know which key goes to which reducer. But same keys, right? So goes to same reducer, that we have understood, that default shuffling. But when you override this partitioner, right? In partitioner class will specify which key has to go to which reducer, right? So I hope all of you understood this, right? Partitioners class. Yes. So can I configure in a configuration, can I configure where this mapper's output has to be stored? Temporary files output has to be stored. Can I configure that? Yes, fantastic. Yes. I hope then all of you have understood well. This is good enough. And basically, we may have to see further, like what are the different kinds of input formats, how to process different kinds of input file itself, then joins, then custom input formats. So basically, custom input format and distributed cache, joining. We thought, right, we will discuss this after Pig and Hive, because it will be really tough if I continue Java, right? Again, beginners of Java, they might find difficult. So basically what I do, this week, let us see Pig and Hive, how to analyze the data, right? Then maybe next week we'll see MapReduce, right? So Pig, let us see now how to analyze data. Again, Pig is a part of ecosystem, right? Meaning, again, it is a separate tool built on top of Hadoop. Hadoop, when I say SDFS and MapReduce framework. So Pig is used to analyze the data. And brief about Pig, we have discussed, so that we have discussed that Pig Latin it uses, we will analyze the data, right? So let us see in detail today how to analyze actual data using Pig, right? So this advanced MapReduce, as I said, let me finish this Pig and Hive and then take up, right? We can configure. Yes, Arun, friends. Yes. So basic flow of this MapReduce is mappers, then combiners, then partitioners, then reducers, right? So let us start looking at this Pig. So basically Pig is developed for non-Java developers, right? So do you know Java? Somebody says no, right? What it is, right? So that is Pig basically kept in mind for non-Java developers. We also say 10 lines of Pig is equal to 200 lines of Java. Meaning here in Pig, you will not be writing in a structured way. Lots and lots of statements, commands you will not be writing. So in Java, we understood we need to first say imports, then we need to extend or implement interface, then we need to override method. Lot of things we need to do for a particular task, right? So now in Pig, you don't need to do anything. You will be using built-in operations like join, group, right? We say load, store, filter, join. That's all high-level commands. That is, we call it as Pig Latin. Pig is the tool name, and language name we call it as Pig Latin. What are those language? It is very much high-level language. So and simple English words like load. We all know what it is. So loading, but don't worry. Now load means we are loading some data into somewhere else. It is not that. But anyway, I will explain that. But other than that, you see store, filter, join, order, limit. So all these are high level commands only, right? So and it is simple English, very much meaningful, and it is very simple, right? So now, why should I go for pig? Again, as I said, number of lines is very, very less compared to this Hadoop programs, that is MapReduce programs. And you don't need to set up some IDEs, you don't need to learn how to write these Java programs itself, right? And then you don't need to create jar file, move it to then run, right? So development time, if you compare, we say 1/16 of development time, because code is also more. So development time, right? You need to use IDEs, you need to plan. First of all, you need to know what you need to be writing as mappers, what you need to be writing as reducer. Problems based on problem statement. If you recall last week, I said if we have to count, right, total number of employees who are getting more than 40,000 salary, we may have to do again second stage aggregation, right? That is at reducer. So we may have to plan, if I have to aggregate at reducers, what I have to do on mappers, all these things at development time. But here in pig, just as I said, as I repeat again, it is just high level commands like load, store, filter, join, and performance is on par with our MapReduce. That is for sure, right? So now MapReduce we all understood. It is powerful model for parallelism. That means it provides opportunity for parallel algorithm, parallelized algorithm, meaning, so if you have multiple blocks, right? So n number of mappers run in parallel. And this is based on rigid procedural structure. What is procedural? Basically contains systematic order of statements, functions, commands for performing a task or to do a task, right? So series of well-structured steps and procedures, we call it as procedural structure, right? We need to, in Java, we need to follow this. But somewhere we feel it is desirable to have high-level declarative language. Declarative mean non-procedural, right? High level, again, as I said, just you say join the data tables will get join. But if you have to do that join, simple join in MapReduce, right? You may have to first know how to read multiple data sets itself. Join in simple MapReduce Java programming is not easy. Here it's only one command. You just say join, so it will join the data sets. As simple as that, right? So now that's where we say high level declarative language, non-procedural or high level, right? It is similar query where it is similar to SQL query where user specify what and leaves how to the underlying processing engine. So you will just specify, as I said, join, but you will not worry how it joins, right? You will leave rest to the pig itself. So again, to see why pig, right? So Java not required, can take any data, means you can process any data, structured, unstructured, semi-structured data. Simple reason many of us go towards pig, because it is easy to learn, easy to write and easy to read, right? Though we say similar to SQL, but it is learning curve compared to SQL, pig is very, very less. Right? Very few commands, that too very much similar to English. Limit, join, filter, right? So for a complex logic, for example, last week we have discussed de-identification of healthcare data, right? What did we do in that de-identification? We have written encryption logic, cryptography, right? We have encrypted data. So if you have to do those kind of operations, it is not possible in pig. You want to encrypt and keep data, it is not possible. So what you may have to do, we may have to write Java application and create user defined function out of that Java and call that user defined function itself in pig. We can do that. That's where we say pig is extensible by UDF, right? So provides common data operations, join, ordering, and it provides complex structures, nested data types like tuples, bag. We will see this what it is. Basically, pig is good for ADOG queries. Ad hoc means it is for a specific problem or task. It is not a generalized query. So now quickly you want to run through, Pig can be a good fit, right? An ad hoc way of creating and executing MapReduce jobs on very large data sets, we can use Pig. One of the reason, as I said, the development time itself is less compared to MapReduce, right? So quickly you want to check some algorithm for a specific task or a specific problem, that is ad hoc. And it is open source and actively supported by community of developers, right? So is Pig acronym or something? No, no, it is just named after the animal, right? So all Hadoop, if you see, it started from Hadoop itself, elephant, pig, right? So now, again, maybe one of the reason is pig eats anything. So here, as far as Hadoop is concerned, it can process any data. So maybe that may be the reason. So now, but again, it is just an animal name, right? So now, where should I use pig? Some of the use cases. First, we need to understand pig runs on top of Hadoop, right? Meaning Hadoop, what do I mean to say? That is HDFS plus MapReduce, that is file system plus processing environment, that is Hadoop. So now pig sits on top of this, meaning pig pig runs on top of Hadoop. So now when you submit some job high level commands, Pig internally converts into MapReduce job and runs on this data. So please don't think whether you can get the source code of that MapReduce. No, Pig is not a source code generator. Pig converts all your high level commands like load, store, filter, join, order, all those high level commands into MapReduce jobs, we can say, and runs in parallel maps and reduce again on Hadoop data. So as a developer now, you don't need to write MapReduce code. You just read a high level command. So it is on top of Hadoop and makes it easy, it makes it possible to write complex jobs to process large volume of data quicker and efficiently, quickly and efficiently, right? So I hope all of you understood this. When you submit command, what happens? Again, internally it converts into MapReduce job and runs. If you see some of the use cases, right, where we can use Pig, we say time sensitive data loads. What is this? See now loading large volumes of data, right, becomes problem as the volume of data itself increases. Meaning more data, longer time it takes to load, right? Simple example, one server, if it is huge data, may take 12 hours, 1 day to process the data, single server. Because as I said, Pig sits on top of Hadoop, so it is able to scale across multiple processors and servers. It makes it easy to process massive data sets in parallel. Again, because Pig uses internally Hadoop, MapReduce, which make it easy to process massive data sets fast and in that too in parallel, right? In parallel, that's where we say fast, right? For example, one server, 12 hours, assume for a data. If you put 24 servers run, we can say within 30 minutes I can finish the job, right? That is the advantage of distributed file system, because Pig sits on top of distributed file system itself and runs and uses Hadoop itself, environment itself. So time sensitive data load easy. Pig builds MapReduce jobs behind the scene to spread load across many servers. Again, right? That is the advantage of scale out, right? Distributed file system, MapReduce, that is Hadoop. Now, processing many data sources. Pig supports many relational features like join, group, and aggregating the data, right? So now that's where if you are getting multiple data sources, it is easy to process. Pig supports many relational features and makes it easy to develop and manage multiple data sources. Analytical insight through sampling, we say. One of the Pig strength is its ability to perform sampling of large data sets. So what is sampling? Sampling means subset of data picked up from random distribution. So Hadoop, normally what happens? It splits and distribute across multiple machines, right? From that random distribution of data, selecting some subset, right? So by that is subset of data from random distribution, so picking up from random distribution of data, just small data, right? That is sampling. By sampling with a random distribution of data, we reduce the amount of data that needs to be analyzed and still deliver meaningful result. So that's where we can say analytical insight through sampling, right? Meaning, some use case you might be wondering, why do we read sampling, right? Say for example, you have written some program. You want to test the program. You are not worried about data. You want to test logic, whether it is perfect or not. Instead of running on terabytes of data, you can say for that data set, sample with maybe 10%. So you can analyze that's where you can analyze your query itself, right? Algorithms itself. So that's where I said we can reduce the amount of data that needs to be analyzed and still deliver meaningful results by using this sampling. Then you might be wondering, if all these features are there, then why we were talking about again MapReduce, right? So there are some situations where where we can't use Pig. That is really nasty data formats. We can say completely unstructured data, video files, audio files, raw human readable text, just PDF files, or say some hotel portal, right? I will give you some list of hotel portal. I will give you huge list of reviews and ask you to maybe read that review itself and take generate details about the reviews for a particular hotel. Say you are managing that portal is managing 100 hotels, and users have given reviews for individual hotels itself, and then we have millions of reviews. You have to read that reviews and then segregate which one is best out of it. Say for example, some user wants to look at the good hotel near airport. Maybe there are multiple hotels near airport, so based on these reviews you have to pick what is the best. So these kind of complete unstructured, I mean to say raw human readable text. Also this kind of logic, again, it is not easy in Pig, meaning complex logic. So there are two maybe you can say situations where we can't use Pig. One is completely unstructured data. Data like image files, audio files, video files, right? So one more is complex logic. So maybe encryption, best example, right? We can't do. So if it is completely unstructured data, Pig cannot manage, and complex logic, it is difficult to use Pig, right? But yes, again, by using user-defined functions, we can at least try and process some of the things. We will see that as we go ahead, right? So that is the limitations of Pig. And perfectly implemented MapReduce code sometimes run faster. In Pig, what happens is when you write high-level commands, It converts internally all these commands first into plans. So what is that is, first it creates something internally called logical plan, then physical plan, mapping the physical entities, where to read from, where to write to, what kind of data types it has to use, everything at physical entities. Next, map reduce plan based on those physical plans. After preparing all these three plans, it starts executing mappers and reducers. So we may say execution time, right? Maybe little more. Initially, couple of slides before I said it is fast. I was referring for development time, right? So now what I am talking, it is execution time, right? So you are good at, you want to write map reduce code, and then you want to optimize code, and then you want to get this runtime faster, then you might go for writing map reduce code itself, right? And when you would like more power to optimize your code, meaning assume you are really good at, assume you are good at Java, and then you want to optimize your code yourself, not depend on Pig. So this, but anyway, ultimately, if you see, this is the main reason. So complete unstructured data, as I said, these two are main reasons. Completely unstructured data and complex logic, you might not go for Pig. So that was the query, right? Anurag already asked, then why do we need Hadoop, Java, if everything can be done in Pig? Correct, right? Is it fine, friends? So now, so basically Pig is command-based language. Exactly, as I said, high-level commands. Like by using this high-level Pig Latin, high-level commands itself, we analyze the data. Is Pig just a collection of Java classes? Pig is developed using Java, but as a developers, we will be using those operators. We call it as high-level operators. Those store, filter. So we will be using them, Manjunath. But Pig, yes, as you say, it is developed using Java. So basically, Pig is a command-based language, yes. So it's only online processing of data rather than batch. No, it is batch, because again MapReduce we are talking, right, Ranganath? Again, see, online, I'm not sure what you meant by online, but anyway, batch processing is what we are referring again, right? So does Pig only works on text files? Max, we can say that because you see, friends, all of you, what you need to understand is, in actual real-time scenario, majority, more than 80%, I can say, of the data we analyze is text-based data. Some are entertainment sectors, some video file analytics, weather forecasting, healthcare, some image files processing. So apart from some segments, right, some verticals where we completely look at image processing, right? Other than that, say maybe surveillance, security camera data you want to analyze. So completely unstructured data, right? And then image, other than text files, I meant to say. So other than these verticals, right, majority of times you go industries, we will be getting TSV files or CSV files, right, majority of the time. Simple text files like reviews, PDF files, comments, right? So Facebook data, you may have to read all comments, reviews, all these messages, right? So all these are nothing but text-based data. Go to any sensor data, again text-based data, anything you refer. So TSV files, CSV files, JSON data, XML file, right? So all this data basically text-based files, right? We can analyze this using Pig. So are we comparing programming language to SQL similar? SQL similar, yes, yeah, you can say that. SQL similar, you can say that, Suresh. You can say that because that is Pig, right? It is SQL similar, not SQL, but SQL similar is Pig. We can say this. Now that's what I was trying to do here, right? But again, Pig advantage is internally it converts everything into MapReduce jobs. So Apache Pig is a platform for large data set, though it can do again same thing like as we discussed MapReduce, right? So Hadoop, MapReduce also we discussed whether it is good for small, large, because Pig again sits on top of Hadoop and runs process Hadoop data, so we can say large data. So here I just slipped this, right? Pig is a data flow language. I will come back to this. So Pig is an open source high level data flow system. So what is this data flow means is, as I said, you say first you say store. Let me explain this point here. In Pig processing, right? First statement what we say is load command. So now generally load means we might be thinking maybe from non-Hadoop environment to Hadoop, loading of the files, right? This is big processing load command is it tells it maybe we are telling which file to process. That's all. There is nothing loading or specific things here. So which file to process with schema. So what happens? This command will be getting executed at runtime. So you will be writing file and then you will be submitting it, or you will be querying, you will be issuing the query itself. Now what happens when you say load and file name with the schema, we need to specify. So this is just to tell which file we are loading and then processing. Loading means loading it into virtual, RAM you can say at runtime. So first we need to say load, then we will say all the commands. First load means which data we are referring. First we are pointing to the data to be loaded to RAM and work. Next you will give all commands, processing commands, like processing commands, like say you may say filter. You want to first say filter some data out of it. So join some multiple data sets, then order, finally limit some of them. So all these things are processing commands. So now you see just high level commands you will be using. So now finally you will say dump or store. So these three steps you need to keep in mind. That is, first you will say load, then you will process that data, finally result you will say load, dump or store. Now when I say these three steps, right? So how Pig works is, first when I said first you need to write load, right? First it will load the data to the memory with this schema which we specified as this command. Then it issues this command filter. So when you say filter, filtered data will be stored first. And you can say join with other data sets. Joined data set will be there. Order and limit subset of data will be there. Finally you say dump. It will be dumped to the console. That result will be dumped to the console. Or store means you can also store it result into the file on HDFS. So now we say this dump, right? Dump shows, I can say shows result onto the onto the console. Store, right? Saves, I can say saves result in HDFS. Like normal MapReduce, we will give output directory, right? It will physically, the output will be physically stored in output directory in HDFS. Same way, when you want to store the output, you will just say store. So the thing what you need to understand here is data flows from command to command here. Load, data is loaded onto memory, filter data, join data, ordered data, limited data, then finally getting onto save or showing result, printing on console. So that's where we say data flow language. Pig is a data flow language. Here we have a stream of data which is passing from instruction to instruction or processing. That's where we say pig as an data flow system. So it is open source, high level. We have understood high level means just commands. You don't need to write any code here, like structured manner, procedural manner we can say, as we have seen like in Java, MapReduce. So, and it is data flow, meaning again data, we have a stream of data which passes from instruction to instruction for processing in pig. That's where we call it as data flow system. It provides a simple language for queries and data manipulation, call it as pig Latin. So all these queries, right, we call it as pig Latin, right? That is compiled into MapReduce jobs. I told you, right? Again, internally everything will be converted to MapReduce jobs that runs on Hadoop. So why pig is important? Maybe companies like Yahoo, Google collect large number of data, enormous number of data in the form of click streams, search logs, web crawls, big companies, right? So now we have discussed this use case, that is here. Here, processing many data sources. I told you pig is good at this because it supports many relational features like join, group, aggregate. So processing multiple data sources is easy in pig. So that's where it is important in bigger companies where they collect lot of data source from multiple data sources, right? Click streams, search logs, web crawls, right? And some of ADAG processing analysis of this information is required. ADAG way means some you want to just analyze, understand your query itself, right? Not a not it is for a specific task we can say. So now some of the use cases, processing web logs. For example, you want to find the number of visits, visit duration, rush hours, authenticated users, total number of pages viewed you want to see, right? Processing of web logs. Data processing for search platforms. Search platforms, again, multiple data source we need to look at, right? Searching. Again, pig is good. Ad hoc queries across large data sets. Pig is good. Quick prototyping. So development time is very small, and writing code also we just use high level commands. So you want to quickly prototype algorithms, best is pig, right? For processing large data sets, again sampling, with the sampling feature you can take just subset of data and then analyze it, right? So quick prototype of algorithms possible in pig. Now you see here I will give you these two data sets. One is visits, other is pages. So now in the visit, user, which URL, what time they have visited, all the details we have. And in pages, we have page rank for URL. So you can join this based on this URL. They are common. So you want to know what is the page rank, you can join, right? So now page rank high page rank means that page is good. The page is good, right? CNN. So my blog, you see some crap as less page rank. Crap site as page as some small page rank, right? Less. Page ranks are decided based on the contents, based on the speed at which these pages will download, based on the reviews, based on the people linking, right? All these factors matter. So now, if I, based on this list, if I ask you to find users who tend to visit good pages more, how will you do it? In traditional way, what will you do? You will join these two data sets based on this URL. You will group based on users, all users wise you will group it and find average page rank, and then top of them you will take it after finding average. Typically you will do that using normal SQL way, right? You will join and all. Same thing we'll do it in pig. That is, first, as I said, what we need to do? We need to say load. I told you, right? Load command specifies which file to process, that too with schema. So now we'll define this schemas also on the columns when we say load. So because we need to process two data sets, I can say load this, and then join, and then group by user, average, filter. Say for good users, I say more than 0.5 average you should have. Average of page rank you should have. So now if Amy, see now, if he or she now used more pages which has less, you might not come under this, right? So filter more than 0.5% maybe good pages, right? Users who visit good pages, filtered data. So now if you observe this, first we are loading data, joining data will be joined here, group the data itself will be grouped based on users here at this stage, then average of page rank will be found, then finally filtered record will be there here. So if you see, we say data flow language, this is called data flow language, and this is how we will be using pig, all high level commands: load, join, group, filter, right? If you know SQL, then pig is easy. It is not as equal, same as SQL, because Hive is as same as SQL. This is just like SQL, but load, filter, join, we say. It is not same as SQL, we can say, Joshua. Yes, what do you mean by with schema? I will explain that. See now, you data type you need to specify. That is schema, metadata. Anurag. For example, say employee data. Employee data, say first name, last name, age, salary. Let us take 4 columns we have in a file. When you say load that file emp.dat, right, you need to specify first name string, second name string, say age integer, salary float. You need to define that all those data types. That is defining the schema, right? Page rank means visited more number of times. No, page rank is decided on, as I said, content, speed, reviews, people linking, right? So once we group, why do we need to take average again? That is grouping based on user. We'll keep all users, say after say Fred, right? Again Amy may come. So we are grouping first all Amy records. Then that means all these records are together now based on this user or every user we can say. Then respective group we are finding average of this page rank. So it might be mixed with all, right? So 10 times Amy has visited this, say assume only this page. So obviously it will be 0.9 only, right? 10 divided by again same thing. So now average, that means add it and then sorry, add it and divide by 10, again 0.9, right? If it is same page for 10 times. So like this, first you find, then average, find it and then filter it. Which one mostly used in real time pig or Hive? We will discuss this, Rangana. We will discuss this point. When we go to pig, right? Sorry, Hive, right? We'll compare this and then discuss this point. So now pig is Yahoo, right? Let us see how Yahoo uses pig, because Yahoo has developed this pig and then it has open source too. It has open source it. So now pig, Yahoo says pig is best suited for data factory. So now you might be wondering what is this data factory now, right? So now you see here, data processing. so often split into 3 tasks. Data processing is often split into 3 tasks. One, we say data collection, right? Then we say data preparation. Then third, we say data presentation. So data processing, we can say 3 parts, right? Pig, we don't worry on this. We don't use it on this data collection. We assume data to be already present on HDFS to process. So collection, pig will not fit. So pig is good fit as data preparation. What is this preparation? That is ETL job, right? Extract, transform, load, clean it, right? So now this is data factory. So you all know raw material comes into factory, then gets finished, clean, fix it, then make it product, and then send finished good and send it out, right? So that's what is ETL's job, right? So now this pig, Yahoo says this pig is good as data factory, good for data, best suited for data factory. That is this. So ETL kind of a job we can say, right? So pipelines, data factory contains pipelines. We know pipelines brings logs. In Yahoo, pipelines brings logs from Yahoo's web servers, and these logs have to undergo cleaning step where bars, internal reviews, company internal views, and clicks have to be removed. So that is cleaning. That is ETL job, right? So this is how Yahoo uses it. Yahoo also said best pick you can use it as ETL tool, right? So research also in research say researchers want to quickly write a script, a test theory, quick prototyping. This is how pig is being used. And one more advantage, pig as integration with streaming. Basically it allows Python or Perl script to embed into it and then run on huge data set. Pig integration with streaming make it easy for researchers to make integration of normal Python Perl code. That's how pig is being used in Yahoo. Right? Some of the use cases, like again, if you see last week what we have seen, healthcare de-identification, right? So now initially I said de-identification is difficult using pig, I said, right? So let us see now, maybe after seeing basic queries, let us revisit this. How can we embed that high level, encryption, all those things, complex logics in pig? We will also see. So pig basic programming structure, if you see, you will write all these commands into a script file and then you can run that script file itself. So pig can run a script file that contains pig commands. What are those commands? I told you, right? Filter, join, all these high level commands. You can put it onto a script file and run. For example, pig space script file name. It runs the commands in the pig file. We also use grunt shell. So if you see in actual live production, right, we go to grunt shell. In shell means what? We can submit individual commands, queries, right? Normal Linux shell, what we do? We just give individual queries, right? I am not opened virtual machine yet. Let me start it. So now in basic Linux also we just Linux shell command will just give command by command file system commands, right? ls pwd, it executes command by command. Same way in grunt, that is pig shell, we can also grunt, it is an interactive shell for running pig commands, we can say. This is best, right? Grunt is an interactive shell for running pig commands. One by one we can use it. So it is also possible to run pig scripts from Grunt shell, but actually we don't do this. But it is possible, right? So now in actual production, for a problem statement, we go to Grunt shell, run command by command, and then analyze the data. If everything is working fine, finally we'll put all those commands into script file and then distribute. I hope all of you understood this, right? I will explain this exercise for a maybe again. We have seen this word count example in MapReduce, right? I will show you now same word count example how to do this in pig, right? First we will use grunt shell itself line by line, that is command by command. We'll run individual commands in a grunt shell. Then everything works file. We'll create a script file and then run. I will show you this. So now embedded, that means pig commands can also be embedded inside your Java programs, like how we have embedded this JDBC programming, right? All SQL queries inside Java. Select star from. So similarly, we can also embed this pig commands inside Java program. So embedded can run pig programs from Java, much like your SQL commands. So all these three way you can run pig programs. In our practical, we'll start with grunt shell and then understand in detail. Pig commands can also run in local mode, meaning data which is stored on local, it doesn't use as HDFS. This is for testing, right? So we will see all these practicals. We will see now how to run this on HDFS. So two main components, execution environment. As I said, you can run on local mode, you can run on distributed mode. That is, execution environment itself is one of the component. Next, pig Latin. That is the program, right? So now language we can say, right? So pig Latin is one component and execution environment. So pig Latin is used to express data flows. We call it as data flows. I told you what is data flows, right? So instruction data will flow from instruction to instruction. Before we go to practicals, you need to understand this point as far as pig is concerned. So now let me explain. I think we have discussed this cluster, normal Hadoop cluster, right? Shell basically where command is defined. Yeah, we use shell to run commands, we can say. Yes, Anurag. See now I told you if I give 5 system, how you will create a Hadoop cluster. Maybe because 5 is too small, we'll have one master running both the master daemons, that is name node and resource manager. Rest all will go for slaves. Each slave runs data node and node manager. This is Hadoop cluster. Now as a user, you can use this server or this to load data into the cluster. You can use this machine itself. From Linux operating system, you can load data to this cluster. So load the data, you can submit jobs, you can check results, you can submit Hive queries. All these things you can do from any one of these machines. But it is not recommended because data nodes, so the main daemons are running there, so they will be busy. We need to give resources for that, right? Instead of we using this user as a user or as a developer using this machine, what we do is we will take one more machine in the same LAN, right? In the same LAN, it is attached to this LAN. But only thing is we'll install all Hadoop, same configuration files also we'll keep it here. Hadoop installations, configurations, everything will keep it here. But in the slave machines, we will not mention this IP address, meaning this will neither be a slave nor be master running. So because configuration files you have, when you say Hadoop copy two files to here, so it knows configuration files is here. So Hadoop knows where it has to reach for name node. It will reach here. That is this client library, right? So client library will reach name node, and then it will know where it has to write. If you want to write some data, so through this configuration files, it will come to name node, and then it will write the data to actual data node. That is client library, client interface. Now users or we can say this user machine or developer machine, so we can use this to load data into HDFS, submit MapReduce job, view results, again submit figure high queries, everything. So now when I say pig, right, pig will be installing in only this user machine. You don't have to run on Hadoop actual cluster, means where Hadoop daemons are running, you don't need to go and install. Pig can be installed in user machine. So when you submit job gets executed on the cluster. Please, can I get yes for this point, friends? All of you understood this point. Pig need not have to be installed in all machines. Can I get yes for this? All of you understood this? Thank you, Manjunath, Venkat, Shiva. Yes, Anurag, Madan, Ankita, Tushar, Ranganath, Joshua. Thank you very much. Long time, so I thought let me read out all names, right? Okay, so Joshua, Vinod, Arun, thank you. So from user machine itself, it will be converted to MapReduce. With this is there, right? We don't have to worry. We know that when you read write you do or submit a job, we know client interface interacts with user and Hadoop, right? So from user machine, this is also Hadoop. Make sure we have same Hadoop installed configuration files here. Same configuration files, but we have not configured this machines as neither slaves or masters. That's all. How to configure as in which file you need to configure this if you want this machine to be acting as a slave. That is slaves file, right? So we will not mention this IP in slave machine, a slave file. That's all. Is it fine, Suresh? So see now in core site.xml you will specify where name node has to run. That is there here. In yarn site.xml where resource manager is running, that is there here, right? And in slaves file we will mention IP address of all the slave machines one by one. So everything will be there here. So but in slaves machine you will not mention this machine username. That's all. So it will no daemons will run here. So now if you use this Hadoop copy commands, so client program knows by reading this where it has to reach name node, and name node gives all interaction. So name node gives where it has to go and read the data. Everything will be interacted through this client library. Yes, that's because pig should be top of HDFS exactly. Slaves and master files, yes. There is no separate installer for client. No. Hadoop itself internally comes with library, Hadoop client library. We don't need to separately install some client or something. Nothing. So this Hadoop files plus configurations, if you have here, if you do anything like load data or submit program, internally Hadoop programs itself, right? We have like called client programs. We don't have to say separately I will install client program somewhere. No, right? This is just an interface, right? So now coming back to this diagram, now you see user machine pig resides. Now when you submit job executes on the cluster. So no need to install anything on Hadoop cluster. So I told you pig Latin, right? It is made up of series of operations or operators we can say, and also we can say transformations because data gets transformed from command to command. So these operators are applied to the input data to produce output. We will see now without wasting time. Maybe again for the more than an hour we are discussing about theory, right? We will see that practical, right? So one thing what we have understood, pig turns all these transformations, that is operators, into series of MapReduce jobs. It is just compiled into MapReduce jobs. Don't guess can we get some source code of MapReduce or what, right? It does not generate source code. So for basic data types, atom, tuple, bag, map, we have, right? So let me show you one simple example now. Let me close. So now first I will go to terminal, right? I also have all these pig files here. That is some example programs. So now let me, okay, first if you say just the pig, right, it will take you to the grunt shell. We will be using this grunt shell itself to analyze the data. First step, we'll see how to use grunt shell, right? So quit and semicolon, it will come out of it, right? As I said, I have some of the files here, pig files, some data files. I will come back to this, right? So pig, let us go to grunt shell first. Here data processing, data collection, we don't worry. That means for pig data to be processing, it looks data at the SDFS. So loading, it doesn't worry, right? So loading to SDFS, it doesn't worry, right? So now it doesn't fit. So now for pig processing data, I can say data to be present in SDFS. So this is needed, right? Data should be there on SDFS, right? So now grunt shell, we have come here. Now let me open up one page here. Maybe I have called pig. Let me see. Okay, I have a file called pig data here. That is in Hadoop SDFS file system. I have a file called pig data. If you see, it is 3 columns, integers, and it is tab separated. File is tab separated 3 columns, which is of integer, right? So now what we need to do to process? We need to say first load data. We need to define schema. Then we can run all commands. Finally, we can say dump or store. This always you keep in mind when it is pig. First command is load, right? So now I have come to grunt shell. So grunt shell, we can use it as, this is the definition. So we can use it as to run individual pig commands. It is an interactive shell for running pig commands, right? So that's what I am showing you now. Now you see here, this is grunt shell. First, I will say load command. For this command, I can also give some reference name, right? So I will give it as my data. My data equals to, right? So load this pig data. Fine. So first I said my data, then load, this is user defined name, any name you can specify, right? So load pig data. What is this pig data? That is this, right? So load pig data as schema I can define. Now let me say this is field 1, this is field 2, this is field 3 for time being. So F1 I will specify as field 1, so that is integer, right? F2 again it is integer, and f3 again it is integer, right? Semicolon. So now I have defined data type with data which we need to process. Now in pig, right, without processing, I just said load, right? I can also dump this data. Meaning, you see this, my data, I have just loaded this, right? I have said load it, that's all I have said. Now I can say dump my data now. What dump does, I told you now, it shows result onto the console. So what it is supposed to do now, it is to just load and dump, that's all, right? So let us see this, dump my data. Now it will dump the result. So MapReduce program, it will run and reads the data and then dumps the data to the console. What is the data? That is this. So we have defined a schema. According to that schema, it reads and then dumps it. So these steps you need to remember. What we did now, just said load with schema and then dump this without any processing. We just said load and dump, right? So now you see here, it has just loaded this and dumped this. So what did I say now? If you recall, I said it has just loaded and dumped, right? So that means when you say load and all these commands, it doesn't do anything. Finally, when you say dump, right, it starts processing. That is, it starts running MapReduce. I hope all of you understood this point, right? So dump or store starts MapReduce. Or we can say executing jobs. These two commands, either any one of them. You can also say store. So now what we did, dump. So dump started MapReduce. That means started executing the job, right? So but without, we didn't anything, just load and dump. Again MapReduce ran. So now you see 1, 2, 3, 4, 5, 6, 7, 8, 9. Everything is there here. Only thing you are worried, just some change. Instead of tab separated, it has put comma separated value, that too inside this bracket, right? Let us see this one by one what it is. Before seeing this, let us go one more step, small processing we'll do on this data now. One more processing we'll do on this data now. That is, field 1 is column 1, right? Let us group this data based on this column 1. So now what is grouping? Grouping means, see here, that too I said column 1 based grouping, right? So now means 1, it will see anything is there here. If it is, if any one record is present with 1 again, so it will put them everything into group. It will group them into one place. Again you see here 4 we have here, 4 we have here, 4 we have here. It groups all these 3 records. You see here 7 only 1, but 3 we have 2 records again. So 3 it will put it, it will group it. So group creates records, group of records based on similar key. What we specify. What are we specifying? Column number 1. Let us see this, how pig does this grouping, right? So now for grouping, we need to say, maybe again relational operator name, say now I will say grp data, this is just a name, is equal to, right, group, right? What we need to group? My data, because my data is the data which we have loaded, but this data, right, big data and define schema. So now group my data, right? So by f1. So this is how you will be grouping the data. Group my data by f1. Now if I say again dump, what I need to say? I need to say this name now, grp data, right? Let us see now grp data. Now again, second time we have noticed dump running MapReduce, right? So what did we do? Now quickly to refresh here, data we have at root pig data. So program, I went to shell, right? And then what I did in the shell, first command, what I did, I said my data equals, so load pig data, I said, right? So then load pig data as then f1 colon int, this what I did, right? f2 colon int, then f3 colon int. I defined the schema. Now first what we did, now dump was just dumping the result, let us not worry about that. Now what did I do? grp underscore data, this is the name I gave now, and I said group my data by f1 I did. Then finally I dumped this grp data. Now all these three steps we have done. Let us see what it has done. Can you see the result? At least previous dump we could able to understand, okay, it was comma separated, but this is really tricky, right, to understand. So that is pig data model. We say atom, tuple, bag, map. We need to understand this, right? So now atom means field. So field is a piece of data, right? So atom field a piece of data, that is this 1, 2, 3 or 7, 5, 4, 6, anything is field atom, right? Now tuple is an ordered set of fields. So now this bracket, right, we say tuple. So tuple is a ordered set of fields. Now coming back here, in the previous output, I can say this is one tuple and 3 fields or atoms, right? So 1, 2, 3, 4, 5, 6, 7. I can say there are 7 tuples and each tuple has 3 atoms. Now let us come back here below down. Now again here you see this is one tuple, this is 1 and this is 1. 2 tuples, this is 1, this is 2, this is 3 tuples, again this is 1 tuple. So tuple and atoms we have understood, right? So next we have something called bag. Bag is a collection of tuples, that is this flower bracket. So see now here flower bracket, this is one bag which has tuples. How many tuples? 3 tuples. So bag is a collection of tuples. And finally we have map. Map is key value pairs, right? So keys are string literals in pig and values can be any data type. In pig, right, data model, we can have key value pair like this in this angle bracket. So whenever you see angle bracket colon this is map key value, right? So we can represent data model in pig like this. So map, bag, atom, tuple, right? So now coming back here, first line as one outer tuple and inside the tuple we have one atom, one bag. Every line you see we have one atom, one bag. We have one field or atom I can say. So we have one field, one bag. We have one field, one bag. So how many columns output? 2 columns, right? First column is field, second column is bag. So each bag varies depending on number of records, unique records of that key. So only one record, so you will see only one tuple. 3, we had 2 records, so you can see two tuples inside this bag. So group, I can say now what it is doing based on this key. It is putting all the records of this unique key. It is putting inside a bag. That is this group. It is grouping all the records based on key. Right. So I can say now group collects together records, right, with same key into a bag. I can say group collects together records with same key into a bag. That's what it is. This, right. So for 4, it has collected all these tuples. For 3, it has collected all these tuples. Tuples are comma separated fields, right? So now that is records. You can assume as records. So now tuples. For 4, we have 3 tuples in a bag, right? So how many fields it has done? Output is output of group output I will write, right? Group output is 2 columns. One is key, next is bag. Key means the column which we have grouped on. It keeps as unique field, right? So that is this 1, 3, 4, 7 from this group. It keeps as key. That is key. That is first column. Next column is bag. Group output is 2 columns, key and bag. That is this, right? So any doubt till here, please you can ask me now. Like, so pig runs on user machine and Hadoop and not on Hadoop cluster. No, it runs on Hadoop cluster, right, Manjunath? Pig is stored here. You all have to need to understand this. Pig resides. That means pig installation you will do here, but job gets execution on cluster. Will you tell how to just untar? That's all. Just untar, Tushar. So you don't need to do anything installation here in our VM. Everything is done to us. You don't need to do anything here. So now in the second class I have given PDF, right? So if you want to install your own, you can just follow that step by step. That where to download from, how to install everything. Sudo distributed mode in a single node cluster, how to configure document, we have how to install pig. You can just follow that simple steps. You just download and untar. That's all we do, and also configure Java Home for that. These 3 steps we do: download, untar, Java Home, set Java Home. How to run a script? We will see that, Suresh. Now we will see. Where do you mention delimiter as tab in the data in the load command? Fantastic, Manjunath. See now, friends, this, as Manjunath says, we just said this command, right? Load column number 1 as this, column number 2 as this, column number 3 as this. So now we didn't specify any delimiter. So now pig, right? It takes tab as the delimiter between fields by default, right? Pig takes tab as the default delimiter, right? So for fields, right? For fields I will write for fields. and new line is for records, right? We say default text loaders, they do this. So this is the bag. Each row we have bag, right? How many bags? One bag. You see here, each row one bag with varied tuples inside it, right? So for similar file, it is taking time. For smaller file, it is taking time. How big loading do we need to optimize? Nothing. See now, for small file, you are seeing this. There is no change. But if you use terabytes in a distributed manner, because it is local machine, I have loaded lot of softwares. I'm running it here, right? So that's where you are seeing it. But yes, if you go to actual production, if you have terabytes of data, you will see the difference, right? So can you please repeat tuple atom? I did not get. Anurag, tuples are, sorry, atoms are just fields. Each field, like this is data, right? Now after processing, it has put each field is tuple as atoms here. So now because each we have grouped on this, right? Each tuples is put inside a bag for this unique key. I told you what group does, right? So group collects together records with same key into a bag, so that bag it creates and puts all these tuples. Tuples means each records, right? Complete 3 2 4 here you see here 3 2 4 3 6 8 for 3, right? So that is this. Now again grouping on first column means 4 4 5 6 4 6 8 4 5 7 3 records we have, right? See here 4 5 7 4 6 8 4 5 6. These are tuples. I hope Gopi, Anurag, is it fine, right? Atom, Anu, Arun, right? Yes, fantastic. Thank you. Can you explain how bag is formed based on data you shown? That is this, right? That is this. Bag is formed. It collects records with the same key. What is the key we are grouping on? See here, my data by F1. So F1 key it takes and then it puts everything into the bag. That is, now F1 is the key. For that key, all collect together same key into a bag. Is it fine, Ankita? So final output always store in tuple. Yes, we will see that. Yes, we will. But when you store, it will store as text file. We will see that. So how are we going to use this group? We will see. We will see. And then friends. So are we going to cover map example as well as with the solution dataset, shown dataset, map example? Are you going to cover map example as well with, you mean to say map reduce, is it Ranganath? You're telling map example, I didn't get. You mean to say map reduce? Map data type. I didn't get still. See now that's what we are doing this, each data type we are mapping it, right? It is integer. I will show you now as we go ahead, right? How to process data, you will all understand well, right? So now I wanted you to understand what is this big data model first. So data model we have all understood now, right? We have external, some complex data model also, that is this bag and tuple we have seen. So these are they are from pig itself, pig data bag, pig data bundle. This map is from Java, and all this integer, long, float, double is again Java. So string we say char array. We also use byte array, right? So these are all the data types. This data model I wanted to explain. So now let us go step by step how to process the data, analyze the data, right? So now for this explanation, first I will get into this. I prepared one practicals text file. So we have seen this, how this data model works, right? And our data model looks like. And if you want to group, you can group by 2 columns. You can also do that. So if you group by 2 columns, so everything will be put in a group and then bag. We will see this now. Now let me explain this use case. Or it is exactly mid of the time. So please let us take, say, 10 minutes break, right? So let us take 10 minutes break and then come back and continue this use case. Now if the data is there like this, how will you analyze and then find? We will see this, right? Please, can I get yes for break, friends? So let's take break. Exactly. We'll do that. How to process comma separate? Exactly. We will see this all, Madan. Thank you. Yes, friends, I hope all of you are back. Please, can I get yes in the chat window? Thank you very much. So these operators itself, if you see, we have divided based on the categories. Meaning based on say loading and storing, we use load, store, dump, right? As I said, one more important point, what you need to remember, store and dump only starts MapReduce. This start execution of the job, right? So now filtering, filter, distinct, for each, stream, these commands we use. Grouping and joining, join, co-group, group, sorting, order, limit, combining, splitting, union, split. So let us see one by one how to use this to analyze this data. So these operators itself we use in our script, right? So now pig also includes concept of data being null, meaning if some of the columns of the data is null, right? So now pig doesn't generate any exceptions. Pig doesn't create any problem. So data of any type can be null, we say. So in pig, when a data is null, right, it means the value is unknown. That's all. Null value. For example, see like this, student role we have here, right? So now student, you see this is empty here. In the second row, we don't have age, right? So now first, if you have to do this, we have to process this data. What we need to do? We need to say load, right? Again, we have loaders like binary loaders, binary files. So pig storage. Again, this is now assume this student file itself is comma separated value, right? So CSV file. So now it defines delimiter by something. So now comma separated value, we need to pig storage we use and then we say delimiter. Text loader, it loads line by line. Default, this is this new line character. We have seen this, right? We have CSV, we have XML loaders, all these files. So now if you have this comma separated value, files and students, first what we do, we say load student using pig storage and comma. So that means if it is comma separated value, we are separating it by, we are telling this pig to see at this delimiter. So name char array, age int, GPA float. So that is char array int float. That is this char array int float, right? Now you can define like this, and dump A, we all know it just dumps. Can you notice this second row? So second row null value, right? That's where I said it doesn't create any error, right? It doesn't create any error for this null value, right? So now group A by name, right? Group this A by name. What is name? Name is first column here. That is this, right? So we understood it creates again field and bag for all the records similar to this field, right? So all of you now you understand. I think now you are getting it. So now Joe here two records we have. So it has put inside a bag. Field and bag, right? Field itself, it creates this by, we are saying group A by name. So this field itself, it puts here as key and then it prepares bag for that key. Sam, we have one record. John, Angel, we have one records. If you have multiple records repeated again with these names, you will see that here. In the same bag, I mean to say, right? So now we have co-group operator. We have co-group, that is we can group multiple data sets. Here, this group, we have grouped one single data set, right? So co-group can use multiple data sets. A, B, A I have student, B I have student role, right? So now the same data what we are talking here, student and student role, right? So we have this co-group A by name, B by name. So now Joe, it sees Joe from A, Joe from B, right? See now you see this Joe and Joe from B and this three fields Joe. So now it creates two bags for A, one bag for A, one bag for B. I hope all of you understood this, right? So now one more point I want to specify here. When you say group A by name, right? So this is field, this is bag, right? So this bag, it keeps as this name only. This bag column name is A. I hope all of you understood this, right? So now let me repeat again. X is equal to group A by name. This is the command we are grouping. We are grouping A data, right? A relational name, right? So now result of this group command has two columns. One is field, one is bag, right? So this bag it names as A, which we have grouped down. Same way, coming back here, we have two bags here. Co-groups A by name, B by name. Means we have two bags here, right? We can see two bags here. So now this bag it names as A. This bag it names as B. How many columns output now? Co-group, co-group field, bag 1, bag 2. Three fields are there here. Three columns are there here, right? So first column field, next column is bag, that is A, and the next column is one more bag, that is B. It names them as A and B only, right? So now this group, right, is gives key and bag, that is two columns we have known. Now bag name, what is this here? That is this my data. That's what I am telling you. I'm specifying that, right? So let me explain this in detail when we go to practicals. Let us see this. So now co-group we have seen. We have join command. We have join command. So join and co-group perform similar function, but difference is join creates flat set of output records like this. Flat set. Here we say nested set of output records because one separate bag it has for A, one separate bag it has for B, right? And inside that tuples it has so separate bags. So nested set of data. This co-group creates nested set of data, right? But here this join creates flat set of data like this when you join. Now A data is missing here. Actually only we have B, right? So I think I'm sorry for this. I should tell this to support team. I need to intimate this. So now I will do that. Let me show you pages. So join and co-group, right? So that's where we are discussing co-group. What it does, it creates nested set of data. So this joins, right? When you joins and co-group operates perform similar function, join create flat set of output records, while co-group creates nested data output records. So now A, assume it is 1 2 3 4 1 4 2 1 8 3 4 like this, B like this. Now if you say join A by A1, that is first column, and B by B1, that is again first column. Now inner join happens. We all know inner join what it is, right? So first we are doing here equi join, A by this, B by this. We are actually doing equi join, and in the equi join we are looking at inner join. Inner join means return all the rows when there is at least one match from both the tables. Meaning, see here, 1 2 3 and 1 here, 1 1 first column we are joining here, right? So 1 1 it matches, it puts 1 2 3 1 3 flat set of record, 1 2 3 1 3. See this, that's how it joins. So now here one more example I'll show you. Now 4 to 1, right? It comes here and matches. Okay, 4 6 plus 4 9, right? So 4 to 1 4 6, 4 to 1 4 9. See here, both of them are there. 4 to 1 4 6, 4 to 1 4 9. See now here again 7 to 5. We don't have 7 here. Here 7 to 5. We don't have 7 here. So there is no 7 here. That's where I said inner join. So this simple join works as inner join. We can also say left join. You can also say right outer join. We can also say left outer join, and you can also say full outer join. All these things you can use in Pig, right? So that's about join. We will see this. So now union concatenates two data sets. We can say, meaning it merges, to merge content of two or more relations. Now assume A is B, A is this, B is this. You want to union, that is you want to merge them, right? 1 2 4 2 plus 2 4 8 9 1 3. You want to merge them. You can use this. We also have multiple operators, so you can see operators in Apache Pig in this blog in detail, right? So now how to create Pig scripts and run in local mode. I told you for testing you can use local mode, that you can see here, and create your script and run. How to do that you can see here. First a script, I will also show you today how to create a script and run. So but anyway, you can go to this blog and then observe here, right? Also we have something called diagnostic operators. I will explain now brief about this diagnostic operators, but in detail, right? You want to learn, you can get into this blog. So we have developed a lot of blogs. Please, when you get time, you just read it, and any queries you can write to us, right? Now let us see, let me close it. So can you explain union once more? Any ebook? Programming in Pig is fantastic, Gopi. Textbook we have in programming in Pig itself. Yes. Can you explain union once more? Union is nothing but merging, concatenating. So you should have the same columns in both, I mean, data types in both data sets. Like say you have employee data from one state, employee data from other state. You want to join them. You want to merge them, say, not join. You want to join is something like this. We have seen left outer, right outer, previous page, right? So join is that, but merging just concatenation. It puts everything together. So before we look at diagnostic operators, we will see this, right? That is, well, let us start with practicals. first use case, I'll give you, say this is the data, right? So now I want you to find total number of page count, meaning, see, now let me explain what are these data. Now see here, I'm loading this data as web count. Now see here, this is project name, this is page name, this is page count, assume this is page size, that is this project name or language name, we can say page name, page count, then page size. Page size is not important to us, so that's where I put all same. So now what I want is, I want you to find the total number of page count, that is this, for unique page names only for EN. Meaning for all Google, I want you to find total of page count only for EN. If it is Google US, I don't want it to count it. So Google 50 plus Google 68. So it should print Google 118. Same way, it's only for EN. So Yahoo 60, say again Yahoo 40, it has to add and say Yahoo 100. So I hope all of you understood what is the use case, right? It has to leave this, it has to not count this US, Google, US, Yahoo, right? It has to count only this Google EN words, right? So now let me add this another some more, I mean to say. Say again, let me add EN Google, it's 118. If I add 32, then it should become 50, right? So let me add 32 here. So again Yahoo, let me go again here 100, for example. So now assume this is the page count. What are we expecting now? So now EN Google 32, then EN Google 68 plus EN Google 50, it has to give, so total of around 150 now, exactly. This should be the answer. Now EN Yahoo 100, EN Yahoo 40, EN Yahoo 60. So only for EN it has to give, it has to leave, forget about this US. So now it has to total is 200 now. This it has to give. So we are finding total of page count for unique pages and only for EN. So now if I have, say again something EN, let me take one more in it, some new one. Just let me say for example, right, mahoot.com, just for an example. So now say 100, right? So now mahoot.com is also EN, so it also has to print like this, total of this mahoot.com 100. Please, can I get yes for problem statement? Did you all understood this, friends? What we are trying to do now, analyze out of this data. Thank you very much. Yes, Ankur, Madan, Manjunath. So thank you. So now you see here, let me just move this data to Hadoop first. I told data should be there on Hadoop first, right? So now Hadoop, DFS, cat, web count. I think I should have this data already. So yes, I have this data already. So now I'll remove this. Right? Means I will delete it and then copy this, right? RM web count. So now you can see it is deleted web count. Now gedit web count, copy this, right? One more important point as far as pig is concerned, right? If you have data right at the end, please check this. If you have new line character like this, if your cursor is in next line, it also takes this as one record. It gives null point. The execution gets into trouble because you are trying to read some. So now make sure you are ending this here, right? So save it, then Hadoop DFS, put web count to web count. So now I'm just copying this web count here, right? So now if I say cat, can you notice we have added new one, right? So now if it process this problem statement, what we are trying to do, it has to give this result now for us. That is, it has to give Google 150, Yahoo 200, so this 100. So now output also I wanted in descending order. I wanted in descending order. So now like this I want. Now whatever web page count maximum that has to come first, descending order. So output I want exactly something like this out of this data. First command we all understood what we need to do. We need to say load, right? So records load web count. First you give the path of the file, then using peak storage space. Can you all notice here what is space here? So this is just a space. We are not using any comma separated value, tab separated value, or anything else. So now just space. So I can specify that and then complete schema. Char array, int. That is this. Char array, int. What is char array? We have seen the data types. That is here. Char array means string, right? So string, int we are seeing now, right? So now let us see this records first. What is this? This is just name. Any name you can specify here. So records is equal to load. I am doing first. Right? I have loaded into records now. Filtered records. Because before I go ahead, I told you only we need to look at EN, right? So at the beginning itself, we need to filter. That is the best optimized code, right? Instead of you doing some group and later filtering, it is better you filter, reduce it, and reduced data you process further. So this is how we do. This is one of the best optimization if you have to do performance tuning. So this optimization you need to keep in memory, right? So if at all, if you are looking at filter, you need to run first that. So filtered records, right? Filter records. What is this? That is this records, right? By project name en. That is this first project name I have given. First column name is project name, right? So only en. That is only en. I am filtering it here. So I can also say dump now here for this. What will happen? Only en records you will see. That's all, right? You can check this. You can dump at every layer, right? So now I mean to say after every layer you can dump the data and check result, right? So now let us go ahead. Now grouped records. So now group this filtered records by page name, right? So now I am grouping this filtered records now by page name. Fine. Now group filtered records, page name. We all know now Yahoo, it has en Yahoo 1, en Yahoo 2, Then again, just now I created one more en Yahoo 100, right? So you can expect yahoo.com, that is by page name, that is the field here. Then inside bag, you can expect 3 values now, because one more I have added now. So one more I have added now, you can expect this Yahoo having 3 data. That is last 100 I have added now, if you recall. And again, Google also, I hope I have added one more, right? En Google 32. So you should have this bag, again, you should have one more en Google 32. So if you group, and one more, I think we have Mahout, right? Last, you expect Mahout also here, right? So group, this is the output. Now one more thing, this field, this bag, I told it keeps this name itself, right? So bag name is filtered records. That means previous alias name which we grouped on, that same name it gives for the bag. So bag name is filtered records, and this first column field name it keeps as group. So now there is little confusion between group command, that is group operator, and this column name. Both are same. So as a beginner, you might get little confused, but don't worry. As you go on, you will just get used to it. Now, what does that mean is, group command creates 2 columns. One is field, one is bag. This bag, it keeps as previous grouped data name, that is this name itself, and this field name as group. This unique field name as group. So this is column name, this is column name for this column and this column, bag, for this key and for this bag. So once we have grouped, you see here, for each grouped results, records, that is this, we say generate. That is, for each and generate are keywords in pig again. So what are we doing for each line? We say generate group, that is this key itself. So that is this group we are talking about here. Otherwise you will get confused. Generate group, what it is, right? So now group means I am talking about this column name here, and sum of filtered records, that is this dot page count, that is this. In the filtered records I have page count 40, 60, 100. So now for each record I need to generate Yahoo and some 100, Google and some, it is 150. Now it is 200, right? So 200, 150, it has to write like this. That's what we are trying here. So for each we are aggregating here, right? So for each grouped records, generate group. So first time you will get confused. What is this generate group, right? So now let me explain again. For each and generate are keywords. This is the previous reference name, that is this grouped records. For each this grouped records, we are telling generate what it is, column name group, that is this. So Yahoo will be generated for first record, then sum of filtered records, that is this is the name, filtered records dot page count, 40 plus 60 plus 100, so 200, some aggregate it will print. That's what we wanted, right? So once we have this each key total, now finally we say descending order by $1. Order results, what is this? That is this. By $1 means we can also specify column names here by dollar position. So $0 represents first column, $1 represent second column. So $1 is this. Based on this value itself, we are doing descending order. You can also specify here, say total, we say alias name, right? We can also specify alias name like this as total, and then this total I can use it here instead of $1. Because I have not given alias name here, I am using it by dollar, that is position. $1 is second column. So finally, all of you see here, this time what I am doing, I am using store instead of dump, right? So store this sorted result into your output. So this is the directory, it will create and store the result, right? So let me see whether before running this, let me see whether this your output directory is already there. Your output, no, right? So now let us do this. Store sorted result into your output. If I give enter here, what happens? Can I get a quick answer from all of you? Can you make keywords capital? Yes, yes. It is case. It is not case sensitive. Pig. You can all write this. Sorry. Operators, right? Operators. You can. It is not case sensitive. You can write in small letters also. But when you are referring this names, right? It is case sensitive. And function call, method call, user defined function, we call it as user defined call, again case sensitive. Other than that, operators or commands are not case sensitive. I can also go for small case. Now what is my question? If I gave store, what will happen? So submit MRV job. Fantastic. Fantastic. Yes, Tushar. How to do we create a stored in page count? Maybe need to be MK directory, nothing. But I was expecting this Tushar's answer. That is, it will start MapReduce now and create this output. I'll run all these things and then put that result here. Now, one more thing, please observe this very, very important point. Now, you see what we are storing? We are storing this sorted result into this. When you submit this, first it will see what is this sorted result. So now sorted result is order of results. So now it will see what is this result. So this results is for each of this grouped records. Now what will see, what is this grouped records? So that is group of filtered records. So what is this filtered records? Filtered of records itself. That is records is the first command which we have loaded, right? I'm sorry. I'm sorry, friends. So now operator by operator, it has to plan reverse, right? That's what we call it as logical plan. It does one by one. When you give store or dump, then it will start planning all of them, logical, physical, map reduce, plan, and then execute. So that is this, right? Reason I'm asking because you said that we dump output of each step. Sure, you got your answer, is it? That big start processing execute on only when store and dump, both. So the name of the key is group by default while getting results in results using for each. Exactly, Pratmesh. Group's output, it names that key column as group. That is the only confusion first time you need to understand. I hope all of you got it right. Output will be stored into your output. Yes, that is stored on HDFS. Yes, Venkat City, fantastic. So I hope all is fine, right? So now you will see your output here. So quickly let me recap what we have done here in the exercise. See now here we had this data, right? So first we are loading it, then we are saying filter, then we are saying filter records, group filter records by page name. Page name means I think now if I dump this, you will see this, right? You all understood grouping what happens. Each page name, that is second column here, page name wise we are grouping first, and then we are finding sum on the group, right? Finally order it, then dump it. So now next let it print. I will just check and show you output, right? Yes, it has finished successfully. Now it will tell successfully read 10 records, successfully stored 3 records. So read from web count, user output, right? So now let us come back here and see what happened. User output. Okay, it is good. It's created here itself. So now user output. Now can you all notice this descending order? That is what we were expecting, right? Precisely, we wanted this exact data. Yahoo first 200, Google 150, Mahoot 100. So there is a problem statement, find the total page count based on unique value. So this how will process the data. Now let me take this word count use case, right? So now first.txt, I have this first.txt file here, right? Now let me run this and then I just open one more window. Let me run this word count on this first.txt. First step, what we need to do, we all understood this, right? First we will load it, right? Let me change it to first.txt here itself. So first command, as usual, every time what we do, we load it, right? My input I have loaded. Now words for each my input. Now if I say this is the column name and default line delimiter. So every line will be one record here under this column name called line. As I said, text loader, new line it takes, right? So now this is the column name as column name. So by default it uses byte array itself. So now line, each line, that is this is one line, this is one line, this is one line, and again I have a new line here. So all these are each one line. So will be fed as this records here. So now column name is line. Now what I am doing is for each my input, that is each line, I am generating flatten tokenize of line. So what does that mean is, first it will run this tokenize of line. That means it will split based on space. Based on space, it splits tokenize line, right? Next, flatten, it runs on this split data. So every word which is split, it creates as a record in this column. Column name is word, right? So column name, what it is? Word. Now let me name it as column name, column word, so that you will not get confused. Column word, right? So now words for each I am generating this as column word. So now group these words by word. I will name it as column word. I have named it as column word, right? So now let me change it. Column underscore word. So now again, let me explain this again. Flatten tokenize. tokenized line splits the line into fields for each word, right? Tokenized. Same Java tokenizers, right? So now tokenizer, what they do based on space as delimiter, they will split the words, right? So now Spain is same thing, but flatten now. What it does, it will take collection of the records written by tokenize and produce separate record for each one under this. So column word, then group words by column word. So generate, now you see here, after I group, right, for each this group I am generating first column name is group and count these words, right? So let me do this group again now. I am grouping each word which has produced now, right? So now let me dump and show you now. You see here, dump grpd. You will understand well what is happening here. And one more thing before it executes, right? So previous, what did we do? Previous commands, we were looking at this, right? So this records, filtered records, grouped records, result, the sorted result. Then finally we stored that, right? So any operator now you can dump here at any point of time. But if you say quit from this pig session, right, and then come back here, you will not get any operator. You may have to run again. I hope all of you understood this, right? So please, can you all understand now? See here, load. First I am loading this. So each line I am splitting the words and flatten. Each word I am generating the word. Each word I am generating as a record. Now I am grouping them on the each word. You see here, all Hadoop, it has put it in one bag. CentOS in one bag. Spans. So now each word, now it has put it inside bag. So now for each this generate group. What is group? That is this first column, that is the field itself, and count words. Words is this group words, previous alias name, right? So count words means it will count this words itself. It is 5. CentOS 5, right? So like this, it does count. So I think I have done as NTD, right? So now dump NTD. Now I'm just counting it and then dumping it. That is word count. So this is the advantage of pig. Can you see now after apart from load and dump, how many lines of code we need to write in pig? Just 3. But if you imagine that word count here, right? Can you see including this, right? We had so many lines of code. So word count, then map I need to write. Again, map is around say 20-30 lines. 20 lines we can assume. Word count is around say 125-30 lines. Again, reducer around say 1, including this import, say 120 lines. So now all this more than 60-70 lines, right? That's where I said approximately 20 lines of code for each line. So this time we just did word count, same word count, just 3 lines. Can you see it has put all the word count here? So Linux 5, CentOS 5, Hadoop we counted 5, right? See here Hadoop 5. Null again 0. So now let me show you one thing. We have created word count, we have run this, we have understood everything is working fine. Finally, I can create a script file out of this, like this, wc dot, and then run script file itself, right? So now, as I said, if I say quit, that's all these relational names what I was referring, I cannot dump now. If I go inside pig, I need to start fresh. I hope all of you understood that. Now coming back ls here, now wc pig, I have created a script file, right? So wc dot pig. So again we have this my input, same thing, right? My input, load this into line, tokenize, group, then count, right? So how to run this? Pig space wc dot pig. That's all you need to run. So Deepak says not able to hear you. I'm sorry, Deepak, are you back now? Let me type Deepak to log off and log in again. Log out and log in if I am back, is it? Okay, okay. Here debugging is difficult. Yes, that is little challenging around. Deepak, you did already, is it? Okay, I was about to type it. That's great. Good. I'm right, sir. Yes, yes, Arun. So basically, debugging is a little challenging here, right? But yes, we have this debugging tools like diagnostic operators. We use it for it. We'll try to see. But yes, it is not easy. You can say as far as pig is concerned. We will understand this. So now what did I do? I have done word count from Python script also. Script file how to run we have seen, right? If number of lines code is more, if number of lines code is more, I think so. Yes. So now depends on this, right? How you write, how you optimize. Say you might, as I said, filter first you need to use. That is optimization practices, best optimization practices as far as pig is concerned. So like this, we will be analyzing the data, right? So now let me take up this use case. That is customers and transactions file. So this customers, I have data. So this customers, right? I have this data customer ID, first name, last name, age, and profession. Right? First name, last name, age, and profession we have. So transactions, basically each transaction done by all these customers, right? So ID is the link. I do have this customer ID here. So transaction number, date, customer ID, then transaction amount. This is the category. This is the sorry. This is the product inside that category, and this is city. This is state. This is payment type. Right. So like this, we have complete details. Customers, if you see control end, we have 10,000 records. Number of lines you can see here, 10,000 records. And transactions, I have around 1 million records. That is 10 lakh records, right? So that is here. Can you all see here? 10 lakh records. I hope all of you can notice my cursor right here, right side end. So line number 10 record, 10 lakhs. So 1 million record we have. Now let us see how to process this data, right? So now coming back to my text file here, WC word count, I hope all of you understood. Now customers and transactions. Now you see here, first what you need to do as usual, right? We need to load this data. So I hope I have created pig and then I have loaded it. Let me check. Yes, customers and transactions I have here. Customers, all these transactions. You see 1 million record is just 84 MB. You can imagine in 128 MB of a block, right? So how many records we can store? More than 1.5 million records we can store, right? So now that is this transactions we have here. So now we'll see how to process this data, big customers, right? Customers and transaction. So this is a retail data set, right? This is retail data set. So now, as I said, if you remember, I told you if you go inside pig now, you will not, if you say dump, right? We have done all this previously. You say all these commands, right? So group words, say for example, this sorted result. Now, if I say store the sorted result into this, now if I say it will throw error because it doesn't find that because we have logged out, right? So session was closed. Let me give output directory also some other thing. So now you see, so now undefined alias sorted result because it doesn't know what is this now, right? So now let us go ahead. Now newly you need to again create. So now first what I'm doing, I'm loading customer. Again you see here customer ID, first name, last name, age and profession, right? So 10,000 records, first 100 I am taking it here, that is limiting, right? What I'm doing, I'm just limiting custs by 100 and I say dump LMT. So first 100 customers it will limit and then it will filter and then give it to us out of this 10,000 records, right? So now next what I'm going to show you is group customers by profession. That is this profession we have pilot, teacher, firefighter, lawyer, right, carpenter, artist, right? So based on the profession it will group it now. So now after grouping it, now you know what it does, right? Grouping means how it does, we all know now. So after grouping it, we are saying for each group by profession, generate group, that is the unique field, and then count. So for each profession, how many records we have, we are trying to count here. Meaning to say, how many pilots we have, how many teachers we have, how many firefighter we have in this data, data it will give us. For each, generate this. So this is how typically you will be analyzing data in a real world, right? So this is the retail data set. So you will be using now further, right? I will also show you how to join these two data sets, right? So, but actually, yes, as I said, you will be using this type of programs, commands, right, to analyze the data. So now finally it has said yes. Can you all notice here first 100 customer limit and dump what I have done? First 100 customer it has limited. 4001 Christina Chung, right? So now you see here 4001 Krishna Chung, first 100 customers it has limited till Roni. So now let us go ahead and find how to group this profession and find the total number of each professions, right? So total number of records for each profession, let us find now. So what I'm doing, again group by profession, then count it, that's all. Only 2 commands, right? So this will print group wise what is the total. So next we'll see what are these transactions. So transactions, we have transaction ID, date, which customer, amount, again category, that is char array, and inside that product, city, state, type, payment type, right? So now I need to first load, as usual I am loading it. So now you see here what I am doing, I am grouping by customer ID of this transactions. So if you are grouping by customer ID, I think you are getting to know what we are trying to do now here, right? So next, if I group on that customer ID, I can find for each customer ID generate sum of transaction amount. Means for each customer ID, what is the total sales he has done, right? So for each customer ID, that is this. So now if you see, that means this customer ID might be repeating further, right? So let me show you this, control CFV, right? So now you see here it has repeated here, it has repeated here. Now see so many records it has repeated, right? What are we trying to find? This customer ID wise total of this sales is what we are trying to find, right? So many customer IDs, see now everywhere it is present, right? Maybe it is 1 million record, it is too much. So but I hope all of you understood this, right? Customer ID wise totaling, we will see that now. So can you all notice here, each individual, we have done this now above. Let me come back to this. Group by profession and count we have done, dump count. Now you see it, it has put actor 196, coach 199, judge 189, right? Can I get a quick answer from all of you? What is this 83? Is there any IDE? No, in Apache we don't have, but yes, HUE, like commercial products like Madan. So Cloudera as this HUE where you can have UI for pig. How to create a file directory in SDFS? Do you always need to move from local file system? Exactly. Yes, yes. Suresh. So how this variables it keeps in memory? How this keeps variables in memory? Yes, yes, it keeps in memory because of this reference name. Different name you need to give, right, Gopi? Sorting, counted, everything. Yes, by the name. Okay, so empty you say, but answer is like Chandan has written. Chandan was a null profession, right? Null profession. So Shiva also written Shiva Vallabhaneni, right? So it indicates missing professional values. Fantastic. Missing ones. Yes, Ankur, that is null values for profession, right? So I hope all of you understood. Null profession it is. So that means in this, sorry, in this customers we have null profession columns. Somewhere like this, if you observe this, that's here, right? Somewhere down you can see again. Okay, yes, here, right? So there is null value for profession. So pig doesn't throw any error. We have discussed that, right? Pig accepts null value. Why did we limit then, since the grouping was done on all data set? No, I think, sorry, Prathamesh and friends, I should have told you this. Now limit, I have done it, LMT, I'm not using LMT on group. I am using cust, which is all 10,000 records. I hope all of you understood this point, right? Limit, I was just wanted to show first 100 records, but next group command, I am running on cust, not on limit. Is it fine now, Prathamesh and friends? All of you understood this? Yes, Prathamesh. So those are number of customers with no profession assigned. Fantastic, Ranganath. Yes, fantastic. That's what I expected, right? How can we execute records from final result set? I didn't get Ranganath. How can we execute SUC records? Execute records, is it from final result set? I didn't get. How can we exclude? What do you want to exclude? I mean, final result, you want to filter something, columns or something? I will show you that then. Filter customers with no profession. Okay, okay, okay. See here, whatever we'll use filter command itself, right? Say something like this, right? So now filter this, maybe again you write on this query itself. Now you don't want null values. So now instead of dumping, right? I said dump, instead of dump this count by profession, you can use filter commands. Simple, right? Raghunath? Not final result set. That is when you dump, it is printing onto result, right? So this as this data now you filter it again, then filtered data you dump finally, right? Yes. Is there any function minus? No, no, Venkat Chetty. Not minus, but again count all these things words we have, right? What did we do now? We have done count by profession, right? So now let me show you this transaction. Then transaction by customer ID, right? So spend by customer, for each transaction generate group and sum. That means customer ID wise total sum of amount. Very simple, right? So each customer ID, what is the total sales it prints, right? So after we get each customer ID total sales, I am doing this second column descending order. So what will happen? Top top sales customer will come on first record, come as first record, right? The customer who has done maximum sales will be on top if I do descending order, right? So now if I limit on that data, I will get top 100 customers. Descending order we have done, so we can see top 100 customers, right? So let me show you this. Dump top 100 customers. So now if we have to find top 100 customers, this is the best solution. If you have to write this in MapReduce, really difficult, right? You may have to run chain of MapReduce programs to do this. In a single MapReduce program, it is not possible, right? It is difficult, I mean to say. So now grouping, what we have done, grouping based on customer ID, generating total sum for each customer, then descending order, then limiting them so that we are getting top 100 customers. One of the best use case, right? Top 100 customer sales. Many times your retail industry must maybe doing this, right? So can we use arithmetic operators? No, no. Operations, user defined function given inside itself you can use, Gopi. Not other than that. So what did we do now? We are trying to sort everything and then order everything based on this sales amount in descending, and then put across maximum sales on top, list limit them, right? So top 100 customers. After this, join this top 100 customers by $0, that is first column, and customers by $0, that is again first column. So here you see now, please all of you observe this. For each this generate group customer ID only, second column amount, right? So now I have customer ID itself as group. So customer ID and cust, we all know this is also customer ID, right? In cust first we have loaded, so customer ID here. So I am joining both of them by this top 100 and then customers by this customer ID. Next. And then please check all these things. This is very, very important. Now if you run for each, now I am generating specific columns out of this result. So that means for each you can use to filter some of the columns. Here you see column position also I am changing here. $0, that is first column I want to print. After that $1 and 2 is not there. Straight away I'm going to $3, 4, 5, 6. Finally again I'm writing $1. So like in position of columns also you can change, and you can $2 is itself not there at all here. So filtering of column, you don't want that column, you remove it, right? So like this specific columns, whichever you want as output, you can choose it here in the for each generate statement. Can we all see here top 100 customers who has done maximum sales? Customer 4005 has done maximum sales here. 15,328. Almost just $7 less, second position. So like this top 100 customers we can see here. Right. So as I said, now we have top 100 customers, right? So now let us join these two data sets. Now if I describe this, two data sets have been joined, right? You all know it is a flat set of join, that is flat set of records. You see here top 100 customers group, second double, that is the value total amount from top 100 customers, two columns, right? Group and amount. Amount doesn't have alias name. So now again this is cust. This was top 100 cust. This is cust. In cust we have ID, first name, last name, age, profession. So now let me take just specific columns out of it. Now what are these specific columns here? $0, that is this group, that is customer ID. $3 means 0, 1, 2, again customer ID. So that's where we are not using 2 here. Then 3 is first name, 4 is last name, again 5 is age, 6 is profession, right? Finally we are printing $1, that is 0 and 1 amount. So amount we are printing at the last now. So that's where I said you can change the position also, you can filter columns we don't want, whichever you don't want, right? So now if you say top 100, so now it will list with specific columns this way. So I hope all of you understood how to analyze the data using Pig, right? We have seen a couple of use cases. One was this weblog, one is this retail data set, right? This is how we will be analyzing the data in real world, right? So now we have something called diagnostic operators. Describe prints the schema of it. That's what I have done now, right? So now when I say describe here, that is at the last, this describe what it print, it printed this schema, complete schema, what are this data, right? This describe top 100 I did, right? So that is again for debugging, and explain and illustrate we use for debugging. Let us see what it is. And we also use user defined function. We need to register and define. I will explain this what it is now. I may take just another 5 to 10 minutes extra today's session, right? So I want our cooperation, just 10 minutes, right? So now describe, right, prints the schema like this. We have seen this, right? Now explain what it does is, if you become very good in pig programming later, what you want to do, you might have to optimize, debug your code, right? So you also want to understand how these operators are getting converted into mappers, reducers, like how it prepares logical plan, physical plan, MapReduce plan. So you can use explain. So explain prints logical plan, physical plan, and MapReduce plan. So logical plan means it is pipeline of operators, one by one, one by one. It first generates a pipeline logically. First you run this, second you run this, like this. First it runs logical operators, right? Let me show you this result when it finishes. Now let us see what is this logical operator, logical plan, sorry. So say now if you have div grpd average like this, then you say explain, it prepares a pipeline of them. First this divs, second after this, third after this. So it prepares pipeline of them, what it is behind, and then physical plan. It also prints physical plan, where physically where it has to load the data from, what type of data it has to use, tuples, data models it has to use, what type of bag it has to use, finally where it has to store physically, right? After optimizing logical plan, pig produces physical plan. This describe physical operators pig will use to explain the script, right? Finally it prepares MapReduce plan like this. So map plan, this operator, right? Combine plan, this operator. See here, finally we have reduce plan, this operator. So everything it will plan, then run, right? So when you want to debug this logical plan, physical plan, then MapReduce plan, you can use explain, right? So same way we have illustrate. Illustrate, when you run, right, it shows each step what is the data. Each step what is the data it shows. Illustrate, right? So now let us see this, whether it has come, output has come or what. Please, can you all observe here? We have selected columns here. Then last column is amount. So ID, first name, last name, age, profession, amount, right? So one more thing, you notice here, it is not ordered now. It is not ordered in the descending order now. Can anybody guess why is this? We lost the order, maybe maximum value somewhere down there. See here, 14,000 is down somewhere in between 13. Can anybody guess why is this? Pig is awesome. Any limitations? We have discussed, right? Any complete complex structures we cannot do, and debugging is little tough. Apart from this, Ranganath, it's fantastic, as you say. In join, we did not mention ordering. Fantastic, Pratmesh. Pratmesh answered well. That's what expecting, right? So after this join, right? So here I did see here I did top 100 customers, but I have done this join. This join will disturb the order. After join, you want again this S1 based, that is this $1 again you want to order. You need to again say descending order, right? So here I have done it basically for you to for me to display here output, right? So now I hope all of you enjoyed this session. Now let us see. I think we have loaded this, right? We have loaded big customers. I think now uh, this this dump by count by profession we have still here we have seen, right? I can say here explain here, right? Explain dump by profession. Count by profession. See now it has prepared internally when I said explain, right? Once when you become good at pig, you want to know what is this logical plan, physical plan, right? When you say explain, it has printed. Now you see all these operators, customers, what it is done, group by profession, what it has done. So it sorry, it plans for each operator. Then physical plan from where to read, where to write it to, what kind of operators it has to use, right? Tuples, data it has to use, right? Finally, MapReduce plan. So map plan, what are the operators? Combine plan, what are the operators? Reduce plan, what are the operators? Same way, I can say illustrate. Step by step output it shows. So each command, what is the output it shows? See here, sorry. So this is for testing. It is not all the output it is printing. First point you need to understand, right? So we say illustrate, right? Each level, see here, cust what it is, group by profession what it is, count by profession what it is, right? Assuming this writer, one record, two record here, okay, you'll understand. Okay, that means two records if it is coming from this customer ID, right? So now this group by profession, what it is doing, it is putting everything into this bag. So two professions, it has two complete records, it is putting it, and then a writer based on this writer, that is profession itself. Finally we are counting it, that is count. So like this you can debug your output at each stage. We say illustrate, right? Illustrate, it shows step by step execution of sequence of statements, and we use this to review how the data is transformed through sequence of statements. Basically this illustrate allows us to test our programs on small data sets and get faster turnaround. So we use user defined functions if it is something complex logic like healthcare use case what we have discussed, right? So I think we will see this tomorrow itself. I will just run through this tomorrow itself, healthcare data set, and then you can healthcare use case, like how to write user defined functions. Tomorrow when we start, I will explain, right? So, and all these eval, aggregate functions, load functions, we have all these blocks, right? So, and this healthcare use case challenge we will see tomorrow. You can also take this assignment which is then in your LMS, big data assignment you can run through. Please visit all these blogs that have been listed and shared to you, right? So that will be really helpful. So fantastic, friends. Does join order data join column? Order the data on the join column. It will not order. Basically, it maps. That is inner join. We say it as, right. It lists all the values, at least one from both the data set. It has to have the data. Join column value. If you say name, in both the data sets, it should have that name. Inner join. Shiva. So then you can do, yes, Shiva. Then you can do joining. Sorry, sorting, right? Descending order, ordering, not sorting. So now I hope all of you definitely enjoyed this session. Tomorrow, probably you execute this healthcare use case and see. If it is not possible, I will show you tomorrow how to use this big script. So let tomorrow we'll start with the Hive, right? So before that, as I said, I will show you first how to run user-defined functions, right? And today, whatever we have seen, couple of use cases, I hope all of you enjoyed. So let us come back and see tomorrow. Take care, all of you. Bye bye, friends. Thank you very much.